with those quick tests, I'm going to start today's lecture. And I know that you may not be able to see my face at all times, but we'll try to adjust to the necessary changes whenever you give me any feedback. All right? Okay, so let's start today's lecture. And today we're going to finish the summary of mass moment of inertia. And after that, we are going to move on to general motion, but in three-dimensional configuration. So we are on mass moment of inertia. Today, and we will finish the summary. And then I will give you maybe one example. What is the example number now? Was that 20?
I think 22, right?
22?
I think so.
Last one was 21.
Okay, so it's 22. Thank you, Mike. Thank you, Christy. Okay. All right. So that's today's plan. And in the meantime, homework number 6 will be issued. Just wait for my email. So that's going to be today's plan. Okay. Now, let's start with a summary. In calculating the mass moment of inertia, you know that on Monday, I talk about this. I'm sorry, not Monday. I was sick on Monday. Last Friday, we said the first property is property of symmetry. Right? We talk about property of symmetry. And the next property is what we call property of equivalence. So what is property of equivalence? The property of equivalence has something to do with property of symmetry. From property of symmetry, we know that if you define a two-dimensional coordinate system like this, you have x, you also have y, defined like that. The mass moment of inertia of a, suppose we consider a triangular plate, configured like this. In this case, you can define an ix, iy. When I say ix, iy, that means we are using these. We're using this. We consider these two axes. That's ix, iy. And that is the same as the value of ix, iy are the same as the value of ix prime and iy prime. And here, if I define this to be x prime and the y prime, of course, in this case, y prime is just y. For the green triangle, I can also define ix prime and iy prime. From here, property of symmetry means this ix is the same as the ix prime. That means if you mirror with respect to the y-axis, ix is ix prime. Same thing as iy and I prime. That's the property of symmetry, which means that if you mirror it with respect to the y-axis, the result is the same. If you mirror with respect to the x-axis, it's still the same. That's what we talked about last Friday. So what is property of equivalence. Property of equivalence is this. Now suppose we consider the same triangle, which is this one. And the value of Ix for this triangle is the same value of the Ix of this triangle. So this one has its own Ix. And furthermore, if flipping or mirroring this triangle with respect to the y-axis, that is basically by changing this point from here to here, right? If you change the mass distribution from the blue triangle to the red triangle, that's basically by gradually moving this point to this point. And that won't change the mass moment of inertia with respect to the x-axis. Therefore, property of equivalence states the following. That means as long as the peak or the top point of this triangle is on this horizontal line, the mass moment of inertia, Ix, is going to be the same, which means this. Suppose I have another triangle, which is somewhere here. And this distance could be whatever the value you want to use. This may be 0.35 of the length, maybe you call it b here, if this is 0.35b, or whatever the value it is. Even though that this point is not on the y-axis here, it's not at this point, but is along the horizontal line. The mass moment of inertia for this black triangle is still the same with all of them. And that's what we call property of equivalence. Next property is what we call property of superposition. So what's property of superposition? Property of superposition means this. Suppose I have a not so complicated object, but let's make it something like this. An object like that. Now, if I want to know the mass moment of inertia of this object on these two axes, x and y, of course, is the coordinate here. The origin is right here. Suppose we just consider one. Just consider the mass moment of inertia with respect to the x-axis. Principle of property of superposition means this. You can actually dissect this complicated object into the assembly of simple shapes. That means you can do this. I'm going to consider everything to be like this. Which means that we have four objects here. Two rectangles and two triangles. Therefore, when you want to calculate the mass moment of inertia Ix for the entire shape, you will know that this is nothing but the summation of the mass moment of inertia of individual ones, right? So you can say I equals 1 to 4 because we have 4 objects defined. You can say 1, 2, 3, 4. And right here is going to be Ix for each one of them. Now, this definition is very straightforward and simple, but when you apply it, you have to be very careful because remember, we also have this what we call parallel axis theorem, right? So when we use the property of superposition, you have to remember parallel axis theorem. You also have to remember this one because when you calculate this, you cannot use the mass moment of inertia at the center of gravity of individual objects, put them together. That is not correct because right now you are asked to find the mass moment of inertia with respect to a given axis, which is this one right here. We want to know what is the mass moment of inertia with respect to this axis. This is the one we want to know.